Last night, I was so bored, I scrolled through my social media accounts for a very long time. I was on the screen for so long that the feeling of scrolling, like this, got weird. I knew I was scrolling, but at the same time, I felt like I wasn't. And somehow, I suddenly found my phone to be extremely fascinating. It didn't take long for me to switch tabs. I got on Google and typed in, "Why scrolling feels weird?" But I got nothing. Well, I have to be honest. I also don't think I typed in the right keywords to begin with. Anyways, I upped my research skills and found out all about it. And after a few search attempts, I finally came up with the right question to ask. I guess this is the birth of our new vlog series. Welcome to the Jet and Jet series. Episode 1. Do things ever touch? The dictionary defines touching as the state of being in contact. Right now, by that definition, I am touching this cup, while last night I was touching my phone. Because my skin can be in contact with whatever thing I'll hold. Ergo, I am capable of touching things. But here's the holdup. You may be familiar with how things are made up of molecules and atoms. My hands, for example, are made up of tissues that are made up of cells. Chemistry tells us that human tissue is primarily made up of carbon. I won't delve on that much further. I'm going to leave that to the biologists and chemists. Every carbon atom contains protons, neutrons, and electrons. I know they're really small. We can't really see them. But just because we can't see them doesn't mean that they don't exist, right? So these protons, neutrons, and electrons, they are what we call subatomic particles. And the existence of these particles disproves the human concept of touching. Jeremy, back me up here.
Consider this atomic model of a carbon atom. One side note on this is that no one really knows if atoms and their subatomic particles are really designed like this. This is Bohr's model. There's also the plum pudding model, the electron cloud model, and others. Regardless, each model helps us understand a lot of phenomena that involve the behavior of matter. Let's take a short detour, shall we? We now know that neon gas is a stable molecule. It is non-flammable, non-combustible, and non-toxic. Although they have the tendency to asphyxiate, the applications of neon gas range from powering hot air balloons to providing fluorescent lighting to powering lasers in semiconductor research. People are not scared to use neon for these applications because the behavior of neon under various conditions can also be inferred from its atomic model. The same goes for practically every other element out there. Going back to our main discussion, the red spheres represent the protons and the green spheres represent the neutrons. Together, they form the nucleus, the heavy center of each atom. However, the nucleus doesn't really play much of a role in ruining our concept of touching. We have these little white spheres around the nucleus to blame, the electrons. Perhaps the most important idea to take note of at the moment is that each electron carries a -1 charge. Earlier, I said that our skin is made of tissues that are made of cells that are made of carbon. Essentially, when we touch things, the carbon atoms come in contact with whatever material we are touching. Paper, for example, is an organic material which is also made out of carbon. Our phones, on the other hand, are not made out of carbon. They are made of other elements that are metallic in nature. This gives them the ability to be electrically capable. Nevertheless, they still have protons, neutrons, and electrons. Only that the composition of these particles are different. Further, phone screens are usually made of hydrogenated amorphous silicon semiconductors, which is just a fancy way of saying a special type of glass.
So in essence, when I was scrolling, the carbon atoms in my hand were in contact with the silicon atoms of the screen, because my thumb was touching the screen as I was scrolling. But the thing is, it's impossible for two atoms to ever touch. Remember when Jeremy said that the most important idea to take note of at the moment is that each electron carries a -1 charge. It's exactly because of that that the outermost layer of the atoms in my skin is made of electrons, but so is the outermost layer of the screen. With this, we can end up thinking that the electrons in my skin are in contact with the electrons of the screen, but that's not possible.
Similar charges never attract each other because of the direction of force each charged species exert. In this case, an electron always repels another electron. And when two electrons come very very close to each other, the force they exert against one another intensifies, making it harder for one electron to move whatever unit closer to another electron.
So to me, scrolling might have felt like I was touching the phone. But no, atomically and realistically, my electrons and the electrons of my phone were fighting each other. This might seem too far-fetched, but the same ideology also governs other big-scale industries, such as in the electrical field and magnetic storages, electrical transformers, generators, even floppy disks and tape. So, I guess that answers the original question. Yay! So do things ever touch? Although it might feel like it, technically speaking, no. And it's all because of electron-electron interaction. So which got me thinking, electrons are curious little things, are they not? So if you don't agree with me, go take it up with the research physicists studying electrons and other subatomic particles. So when we were researching, we also encountered some articles on particle physics. The gist is,
A long time ago, people thought that materials are non-divisible, meaning that matter cannot be divided into smaller particles. But then, several years after the statement was formulated, subatomic particles, like the protons, neutrons, and electrons, were discovered. A lot of people thought that these particles can no longer be divided. But then, here comes technological innovation. It was then found that the nucleons were composed of quarks, and that interactions between atomic particles are governed by Higgs bosons. Quarks? Bosons. These subatomic particles are much smaller than the protons, neutrons, and electrons. Proving their existence was accomplishment enough. Right now though, it's difficult to pinpoint the real-life applications of the small particles because not much is really known about them. Thus, it's a little too difficult at the moment to try and manipulate them to our advantage. But then again, so was any other discovery, invention, and innovation.
and I guess this video ends here. Thank you so much for bearing with us despite the babbling. See you next time.
Taas mo na konti yung phone.
Na, tama.